Hi guys, this is Manohar and welcome to Tutoralz. Today in this video, we are going to discuss about the topic removed and replaced in the alligation and mixture. Okay, actually this is the fourth part of alligation and mixture. If you haven't watched the previous parts of the tutorial, I recommend you to please watch previous parts of the alligation and mixture tutorial. Okay, so that you can come to know what is the concept of alligation and mixture and also what are the methods we use to solve the problems. Okay, now in this video, we are going to discuss about the topic removed and replaced in the alligation and mixture. Okay, now first of all we need to know what is the exact concept of removed and replaced. Okay, I will take some examples so that you can come to know what is the concept and also how to solve this kind of problems. Okay, suppose consider I have 1000 rupees. Okay, suppose consider in my pocket there is 1000 rupees. Okay, now this 1000 rupees is in the form of I have one 500 rupees note and I have another 500 rupees note. Okay, I have totally 1000 rupees in my pocket, so one 500 rupees note and also another 500 rupees note. Okay, now this is the total mixture. Okay, this is the total mixture, that is to contain this 1000 rupees I have one 500 rupees note and also another 500 rupees note. Okay, now this is the total mixture. Now I am replacing this 500 with 500 rupees. Okay, 100 plus 100 plus 100 plus 100. Okay, now see here. Now in the pocket I have one 500 rupees note and also another 500 rupees note, right? So I am taking out this 500 rupees note. Okay, I am taking out this 500 rupees note and replacing the same 500 rupees note with 500 rupees notes. Okay, now what is the total amount of mixture that I have? See here, this 500 and also 1, 2, 3, 4, 5. The total quantity is again 1000 rupees. Okay, the total quantity is not changing here, but only thing is we are replacing some part of the quantity with some parts. Okay, see here I am replacing this 500 rupees note with 500 rupees notes. Okay, here the total quantity is not changing, but the thing is only number of parts are changing. Okay, see here, if you see here there is only one part in 500. Okay, now in this same 500 there are 5 parts, 1, 2, 3, 4, 5, right? 5 parts in same 500 rupees. Okay, here only parts are changing, but the total quantity is same in the first and second case. Okay, now see here in the second case, okay, suppose this is the second case, this is first and this is third case. Okay, now what I am doing is I am taking out all the 500 rupees notes and I am replacing all the hundreds with 50 rupees notes. See here, now I am keeping this 500 same in all the cases and now I am taking out all the 100 rupees notes. I am replacing same 100 rupees notes with 50 rupees notes. Now for every 100 I will get 250 rupees, right? So I will get 50 plus 50. So there are totally 1 plus 1, 2, 3, 4, 5. 500 rupees. So I will totally get 5 into 2, that is 10 50 rupees notes. Okay. But the total quantity is same. Okay, this is 500, 10 50 rupees notes, that is totally 500. So the total quantity is same, that is 1000 here. Okay, so this is called removed and replaced. In this, the total mixture is same 1000 rupees, but we are replacing the 500 rupees note with 500 rupees notes and also again 10 50 rupees notes. But the total quantity is same, that is 1000 rupees in all the cases. Okay, in this removed and replaced concept, the questions will be like this. Okay, they will replace one quantity with another quantity and they will ask what is the final ratio. Okay, here see here in the first total mixture, what is the total ratio? That is 500 is to 500. The ratio is 1 is to 1. Okay, out of 1000 rupees, okay, out of 1000 rupees, that is total mixture, the ratio is in the form of 1 is to 1. Okay, now see here, there are totally 1 plus 5. There are totally 6 parts in this 1000 rupees. In this 1000 rupees, there are totally 6 parts. Okay. Now, one part is, that is, we need to know what is the value of one part. Okay. So, I will get 1000 by 6, that is 2 3s and 2 500s. One part value equal to 500 by 3. Okay, see here, observe this carefully. Here we are not changing the total quantity, but we are replacing some part of the quantity with other quantities. Okay, that's the reason the ratio is changing in each and every case. Okay, see here, observe this carefully. In the first case, 500 is to 500. So the ratio is 1 is to 1, right? Now in the second case, how many parts there are totally? 1 plus 5. There are totally 6 parts in the same 1000 rupees. Okay, in the first case, in the 1000 rupees, there are only 2 parts. That is, one part is 500 and another part is 500. Now in the second case, there are totally 6 parts in the same 1000 rupees. Okay, this is what happening here when it comes to remove and replace concept. Okay, in the remove and replace concept, we will keep the total quantity same, and also we are changing the total quantity with some parts of quantity. Okay, this is called exactly concept behind this removed and replaced. Okay, in this types only they will ask questions in this removed and replaced. Okay, now I will take another example so that you can come to know an idea how this actually works. Okay, now I will take another example and show you how to understand this removed and replaced concept when it is given in the form of ratios. Okay, suppose consider one example. Suppose there is a 10 liters of 10 liters of total mixture in a vessel. Okay, in a vessel there is totally 10 liters of mixture that is contains milk and water. Okay, milk and water mixture. Okay, now in this 10 liters the ratio of milk and water is 3 is to 2. Okay, suppose assume there is 10 liters of mixture in a vessel, and in the 10 liters the ratio of milk and water is 3 is to 2. Okay, now from the 10 liters I am taking out 5 liters. Okay, I am taking out 5 liters of mixture. Okay, now what is the amount left over? That is, out of 10 liters 5 liters is taken out, the amount left over is only 5 liters. Okay, now in this 5 liters what is the ratio of milk and water? See here, no matter how many liters you can take out from the mixture, the ratio will be same, that is after taking out and after adding, that is the ratio will be same as 3 is to 2. Okay, now I will explain you how this exactly happens. Now see here, out of 10 liters initially there are 3 plus 2, there are totally 5 parts. Okay, in this 10 liters there are totally 5 parts initially. So what is the quantity of milk and water? See here, out of 5 parts the quantity of milk is 3 parts into 10. We will get 5 ones, 5 twos and 6 liters. Okay, in the same way, what is the quantity of water here? See here, out of 5 parts only 2 parts into 10. So we will get 5 ones, 5 twos and 4 liters. Okay, now what is the ratio of milk and water? That is, milk and water is 6 liters is to 4 liters. So we will get 2 twos, 2 threes. The ratio is 3 is to 2, that is initially in the total vessel. Okay, now in this 10 liters I am taking out 5 liters. So okay, now what is the content remaining? That is only 5 liters are remaining. Okay, see here, out of 10 liters I have taken out 5 liters. Now only 5 liters is left in the vessel. That is, in this 5 liters there is a mixture of milk and water. Okay, now out of remaining, that is 5 liters are removed from the quantity, right? So in this 5 liters, how many liters of milk are removed and how many liters of water are removed? Okay, if I find out that, I can find out what is the remaining ratio of the mixture. Okay, see here, out of 10 liters, from the mixture I am taking out 5 liters, right? Now in this 5 liters, there will be quantity of combination of milk and water both, right? Now in this taken out 5 liters, what is the quantity of milk has taken out and what is the quantity of water has taken out? So we need to find out that. After finding out, we will simply tell what is the ratio of milk and water after taking out 5 liters also. See here, out of this taken out 5 liters, what is the quantity of milk? Okay, so out of, what is the ratio initially? That is 5 parts, right? Out of 5 parts, the total quantity of milk is 3 parts into 5 liters are taking out. So what is the milk quantity in this 5 liters? See here, 5 will be cancelled and 3 liters are taking out in the initially. Okay, from the initial quantity we are taking out 3 liters of water, 3 liters of milk. So in the same way, out of 5 parts, the milk water quantity is 2 parts into 5. So we will get 5 will be cancelled and 2 liters. Okay, now there is totally 10 liters initially and we are taking out 5 liters. Now in this 5 liters, the total quantity of milk is 3 liters and total quantity of water is 2 liters. Okay, now after removing 3 and 2, what is the total quantity left over? See here, the initial quantity of milk is 6 liters, right? Now out of 6 liters, we are taking out 3 liters. Now what is the content of milk that is remaining? 3 liters. Okay, in the same way, out of 4 liters of water, we are taking out 2 liters of water. Now what is the water remaining? That is only 2 liters. Okay, what is the ratio here? 3 is to 2. Okay, so after taking 5 liters also, the ratio of milk is to water is same, that is 3:2. Okay, then what is changing here? Only number of parts are changing here. Now I will tell you how to see here. Now in this there are total 5 parts, right? Okay, there are totally 5 parts. This 5 parts is equal to 10 liters. Here also there are totally 5 parts, but here 5 parts equal to only 5 liters. Okay, here what is the value of one part? See here, out of totally 5 parts equal to 10 liters. So what is the value of one part? That is 10 by 5. One part equal to 2 liters, right? One part equal to 2 liters. Now in the same way here 5 parts equal to 5 liters. Now what is the value of one part? One part equal to 1 liter. Okay, the ratio is same in the first and second case, but the only thing is changing is the number of parts or the value of one part. Okay, this is the exact concept behind this remove and replace when it comes to ratios. Okay, now I will explain you once again. See here, you need to understand what is the exact concept behind this remove and replace. Okay, if you don't understand, you can't solve the problems. Okay, see here, what is the exact concept is, initially there are 10 liters of mixture. Okay, initially there is 10 liters of mixture. In this 10 liters, the ratio of milk and water is 3:2. Okay, and then 3:2 in the sense there are totally 5 parts in this 10 liters. Now what is the quantity of milk here? 6 liters in this 10 liters, and quantity of water is 4 liters in this 10 liters. Okay, now what I am doing is, out of 10 liters I am taking out 5 liters. Okay, now in this 5 liters, what is the quantity of milk that we taken out and what is the quantity of water that we taken out? We need to find out that. Okay, out of 5 liters we have taken out 3 liters, and out of 5 liters we have taken out 2 liters of water. Okay, now initially there is 6 liters of milk. Okay, now out of 6 liters we are already taking out 3 liters. Now what is the milk that is left over? Only 3 liters. Okay, in the same way, out of 4 liters we are taking out 2 liters of water. Now what is the water left over? Only 2 liters. Okay, now after taking 5 liters out, what is the ratio of milk and water? That is same 3:2. Okay, now you can ask me what is the difference between initial and final. But initially there is 5 parts in this 10 liters. Okay, now here 5 parts equal to 5 liters. Okay, now what is the one part value? Initially one part value is 2 liters, but here one part value is 1 liter. Okay, the ratio remains same in first and second case, but only thing that changes is the number of parts and also the quantity of part, or we can also say it as value of part. Okay, in the first case the value of one part is 2 liters, and in the second case one value of one part is 1 liter. Okay, this is the exact concept in this removed and replaced. Okay, no matter how many liters you take out from the mixture, the ratio remains same in the first and second case, that is before removing and after removing. Only thing that changes is the value of number of parts. Okay, this is the only concept you need to understand in this remove and replace. If you understand this, you can simply solve the problems. Okay, remember this, no matter how many liters taken out or how many liters added, the ratio will be same in the initial and final. Okay, suppose I will take another example. See here, suppose there is totally 20 liters of mixture, and in this mixture the ratio of milk and water is 2:5. Okay, now I am taking out 10 liters from this 20 liters. Now what is the ratio after taking out 10 liters? The ratio will be same, that is 2:5. But the number of parts differs from first case and second case. Okay, in the first case the number of parts will be, that is 5 plus 2, there are totally 7, 20 by 7. Now in the second case the number of parts, that is part value, is 10 by 7. Okay, the value of part changes, but the ratio remains same after and before adding the or removing the mixture. Okay, you need to understand this. If you haven't understand, try to watch it once again until you understand, because this concept is very important in this removed and replaced. Okay, if you have understood this example and the before example, you can simply solve the problems based on this removed and replaced. Okay, now you can ask me how to solve the problems based on this concept. Okay, now I will explain you with one example how to solve this kind of problems. Okay, and also what are the methods we use to solve the problems based on this removed and replaced. Okay, now I will take one example and explain you all the methods so that you can understand how to use this method to solve the problems. Okay, see here, suppose consider there is 10 liters of milk in a vessel. Okay, suppose consider there is 10 liters of milk in a vessel. Now from this 10 liters I am taking out 2 liters of milk. Okay, now after taking 2 liters of milk outside, I am replacing same 2 liters of water into the mixture. Okay, now in this way I have done 2 times. Now what is the total amount of milk in the total mixture? Okay, actually this is the question. Okay, see here, assume that there is 10 liters of milk in the vessel. Okay, in the vessel there is 10 liters of milk here. Okay, now from this 10 liters I am taking out 2 liters. Okay, I am taking out 2 liters. Now after taking out 2 liters, I am replacing the same 2 liters of water into the mixture. Okay, same 2 liters of water to the mixture. Now in this way I have done 2 times. Now what is the total amount of milk in the total mixture? Actually this is the question. Now let's see how to solve this question by using formula. Okay, see here. The formula we use to solve this remove and replace is final quantity initial quantity equal to 1 minus x by c whole power n. Okay, now here final quantity is nothing but after doing all the operations, what is the final quantity of milk in the total mixture? That is called final quantity. Okay, initial quantity is nothing but what is the initial quantity of milk in the total mixture. Okay, now what is x? X is nothing but what is the amount of total mixture we are taking out and replacing with water, that is 2 liters here. Okay, here 2 liters is we are taking out and replacing with water. Okay, so x is nothing but what is the content of our quantity we are taking out and adding. Okay, now what is c? C is nothing but total quantity in the mixture or total container mixture. Okay, now here total quantity also 10 liters. Okay, suppose assume that they have given the total quantity is 20 liters and the total content of milk is 10 liters. Now here C will be total content, that is 20 liters. Okay, C is nothing but total quantity or total mixture in a vessel or container. Okay, now what is N? N is nothing but how many times we are replacing and taking out total mixture. Okay, that is called N. Here we are doing 2 times, right? So the total N value is 2 times. Okay, I will explain once again. See here, final quantity is nothing but after doing all the operations, what is the final quantity of milk in the total mixture? That is called final quantity. Okay, initial quantity is nothing but what is the initial quantity of milk before doing all the operations. Okay, that is called initial quantity. Now x is what is the quantity that we are taking out, that is 2 liters. Okay, now what is C? C is nothing but total quantity, that is total quantity is nothing but 10 liters. Okay, now N. N is how many times we are doing this operation. Okay, that is called N. Here we are doing 2 times. Okay, now let's see how to solve the problem using this formula. See here, final quantity. What is the final quantity? We need to find out final quantity of milk. So I am keeping this final as it is, and initial quantity. Initial quantity is nothing but 10 liters of milk, right? So 10 liters of milk equal to 1 minus x by c. X is nothing but how many times we are, what is the quantity we are taking out, that is 2 liters. So 2 by c is nothing but what is the total quantity, that is 10 liters only. Okay, whole power n. N is nothing but how many times we are doing, that is 2 times. Okay, now if I solve this, I will come to know what is the final quantity of milk in the total mixture. Okay, see here, final equal to 10 into 1 minus 2 by 10, that is 10 ones 10 and 10 minus 2, that is 8 by 10 whole power 2. So we will get 10 into 8 by 10 into 8 by 10. Okay, because 8 by 10 is 2 times here. Okay, now 10 and 10 will be cancelled and 2 5 is 10, 2 4 is 8. So we will get 8 4 is 32, 32 by 5. So 5 ones, 5 6 30.54, 6.4 liters. Okay, after mixing 2 times, the total quantity of milk in the total mixture is 6.4 liters. Okay, in this way we solve based on this using this formula in the removed and replaced problems. But one thing you need to understand while using this formula is used only when the taken out and replaced quantities are same in all the cases. Okay, see here, I am taking out, in the first time I am taking out 2 liters and replacing with 2 liters of water. Okay, in the second time also I am taking out same 2 liters and replacing with same 2 liters of water. Okay, in first and second case I am taking out only 2 liters, that is same quantity. Okay, in that cases only we will use this formula. Okay, suppose assume that in both cases the quantity is different. Suppose assume in the first case I have taken 2 liters out and replaced it with 2 liters of water, and in the second case I have taken out 4 liters of quantity. Okay, and replaced it with 4 liters of water. Then the quantities are different in first and second case. Okay, then we can't use this formula to solve the problem. Okay, because the quantities are different in both the cases. This formula is used when the quantities are same in all the cases. That is, taken out quantity and replaced quantity is same in all the cases. Okay, Now let's see what is this normal or basic method and how to use this method to solve the problems. Okay, see here initially the total quantity of milk is 10 liters, right? Now this is the initial quantity, okay, initial and removed, added, removed, added. Okay, by the end of this problem we will come to know why did I write this all removed and added here. Okay, see here initially the total quantity of milk is 10 liters. Initially there is no water in the total mixture. Okay, initially there is no water and there is only milk, that is 10 liters of milk in the mixture. Okay, now what is the total quantity? Total quantity is 10 liters. Okay, now what we are doing is out of 10 liters we are taking out 2 liters of milk. Okay, out of 10 liters we are taking out 2 liters of milk. Okay, now we are adding same 2 liters of water to the quantity. Now what we will get? Out of 10 liters 2 liters of milk is removed, so the remaining is 8 liters of milk. Okay, now here we are adding 2 liters of water, so the water quantity is 2 liters. Now what is the total quantity? That is 10 liters only. Okay, because we are removing same quantity and we are adding same quantity, so the total mixture will be 10 liters only. Okay, now in this mixture we are again taking out 2 liters of mixture. Okay, so taking out 2 liters of mixture and adding 2 liters of water. Okay, see here, now we need to find out what is the content of milk in the 2 liters and the content of water in this 2 liters. Okay, see here, from this 10 liters we are again taking out 2 liters of mixture. Okay, now 2 liters is mixture here. Initially the 2 liters is belongs to milk. Okay, because there is no water, but here there is water also in the mixture. Now we are taking out 2 liters of mixture, that is milk and water, from the total quantity. Okay, now in that 2 liters what is the quantity of milk and also what is the quantity of water? See here, there are totally 10 liters, right? Out of 10 liters the quantity of milk is 8 liters. Now out of 10 liters we are taking out 2 liters. Okay, now in the 2 liters what is the quantity of milk? That is 2 ones, 2 fives, so 8 by 5. This is the quantity of milk we are taking out from the mixture, so 8 minus 8 by 5. Okay, in the same way out of 10 liters the quantity of water is 2 liters into we are taking out 2 liters. Now in this 2 liters the quantity of water is 2 ones, 2 fives equal to 2 by 5. So we will get 2 minus 2 by 5. Okay, now we are adding 2 liters to the total quantity, that is 2 liters of water to the quantity. Okay, now we will get 8 minus 8 by 5 is to 2 minus 2 by 5 plus 2 liters of water. The total quantity will be again 10 liters only. Okay, now we need to find out what is the total quantity of milk in the total mixture, that is 8 minus 8 by 5. Okay, 8 minus 8 by 5, that is 5 8 40 and 40 minus 8, that is 32 by 5. That is nothing but 5 6 30 and there will be 2 here, 6.4. Okay, the total quantity of milk in the final mixture, that is 10 liters, is 6.4 liters. Okay, in this way we will solve the problem using this basic or normal method. Okay, see here we are taking out 2 liters initially and mixing with same quantity of water. But in the second case we are taking out 2 liters of mixture. Okay, in the initially there is only milk here, but in the second case there is a mixture of milk and water. Okay, that's the reason we need to find out in the removing quantity what is the quantity of milk that is removing and what is the quantity of water that is removing. Okay, and then we can subtract the removed quantity from the total quantity. Okay, in this way we will find what is the quantity of milk in this normal and basic method. Okay, now let's see how to solve the same problem using this units or parts method. Okay, I will explain you what is this units or parts method. See here, initially the total quantity of milk is 10 liters, right? Okay, initially the total quantity of milk is 10 liters. Now we are taking out 2 liters. Okay, now what is the quantity of milk is left over? That is only 8 liters. Okay, now how many times we are doing this? 2 times, right? So I am powering this total value by 2 in the both sides. Now I will get 10 square is 100 is to 8 square is 64. Okay, now what is the initial quantity? Only 10 liters, right? Now we have got the initial quantity as 100, but initial quantity is only 10 liters. Now we need to make this 100 as 10. Now how can we make this? 100 is nothing but by 10 by 10. So we will get 10 and 6.4. Now what is the final quantity of milk? That is 6.4. Okay, now I will explain you once again the units or parts method. Try to understand very clearly, because using this units or parts method we can solve the problems very faster when compared to the normal or also basic method and formula method. Okay, see here they have given the initial quantity of milk is 10 liters, right? So what is the quantity that is we are taking out? We are taking out 2 liters of quantity. Okay, now after taking out 2 liters of quantity, what is the milk left over? That is 8 minus 2, that is 8 liters is left over. Okay, now how many times we are taking out and replacing? 2 times, right? So I am squaring both the values. Okay, I am squaring both the values. If you are doing 3 times, then cube both the values. Okay, now I am doing only 2 times, so I am squaring both the quantities. Now after squaring, how much value I will get? 100 is to 64. Okay, this is the value I got after squaring. Now we already know the initial quantity is 10 liters, right? But here what is the initial quantity we got? 100. Okay, this is the initial quantity and right side is final quantity. Okay, initial quantity is 10 liters in the mixture, but we got 100 liters as initial quantity. Now we need to make this 100 as 10. How can we make it? 100 by 10 equal to 10, right? So I am making this 100 as 10. So in the same way, we need to divide the same value in the right side also. Okay, the value which you are dividing in the left side, the same value need to be divided in the right side also. Okay, now after dividing by 10, I am making this 100 as 10. So the initial quantity is 10 here again. Okay, now the initial quantity is 10. What is the final quantity? That is 6.4 liters. So the final quantity in the total mixture is 6.4 liters. That is here. Okay, in this way we will solve the problems based on this units or parts method, normal or basic, and also formula method. Okay, see here, when compared to this normal or basic method or formula method, using this units or parts method, you can simply solve the problem so quickly in a fraction of seconds. Okay, that's the reason always try to use this units or parts method and normal or basic method to solve the problems. Okay, see why I don't suggest you to use formula method in solving the problems is, see, suppose if you want to solve the problem using this formula, you need to remember the formula. And also you need to write down all the data given in the question in the form of formula. Suppose in the question any data is missing, you can't solve the problem unless you know the normal method. Okay, that's the reason always try to use this normal and also units or parts method to solve the problem. Try not to use this formula method to solve the problems in any tutorial, not only this alligation and mixture, it might be time and work, it might be speed, time and distance, or any tutorial. Okay, always try to use what is the exact concept and also what is the exact method to solve the problems. Okay, see actually I don't like to use the formulas in solving the problems, because you need to memorize the formulas. Okay, you need to write all the data given in the question and substitute the values and finding the answer. I don't like this process actually. That's the reason I always suggest you to go this basic method. Okay, if you know what is the exact concept and what is the exact method used to solve the problems, you can solve any kind of question given in the exams. Okay, of course it takes some more time to solve the problem, but you can solve any kind of problem. Okay, but by using formula you can't solve any kind of problem. When the question is very tough, you can't solve the problem unless you know the basic method. Okay, that's the reason no matter what tutorial it is or what topic it is, try to use basic or normal method and also know what is the exact concept behind that topic. Okay, now I need to tell you one most important thing based on this formula method and also units or parts method. See here, the values of final quantity and initial quantity in both the methods are always the values of quantities that is not getting replaced. Okay, but not the quantities that is getting replaced. Okay, see here I will take one example and explain you briefly. See here, suppose assume that there is 20 liters of mixture which contains milk and water. Okay, there is 20 liters of mixture which contains milk and water both. Okay, suppose assume that from this 20 liters I am taking out 10 liters and adding 10 liters of water. Okay, from this 20 liters I am taking out 10 liters and replacing with 10 liters of water. Okay, here every time we are adding water. Okay, that's the reason here initial quantity and final quantity must be the values of milk here. Okay, I hope you are understanding. Try to understand this. See here I am taking out 10 liters of total mixture. Okay, but adding 10 liters of water. Okay, every time I am adding water into the quantity. Okay, that's the reason here initial and final quantity must be the values of milk. Okay, which is not getting replaced. Every time here we are adding water only. We are not adding milk here. Okay, that's the reason initial and final quantity must be milk here. Okay, in the same way, if in 20 liters, okay, if I am taking out 10 liters and replacing 10 liters with 10 liters of milk. Okay, I am replacing 10 liters with 10 liters of milk. Then every time I am adding milk here. So initial and final quantities must be the values of water. Okay, if I am replacing the quantities with water, the initial and final quantity values must be in the form of milk. Okay, if I am replacing the quantities with milk, then initial and final quantities must be the values of water. Okay, always remember the initial and final quantities must be the values of quantities that is not getting replaced. Okay, every time I am adding water to the quantity, then the final and initial quantity must be the value of milk. Okay, every time I am adding 10 liters of milk to the quantity, then the initial and final quantity must be the value of water. Okay, whichever the quantity that is not getting replaced, this initial and final quantity must be the values of that quantity. Okay, if milk is not getting replaced, the initial and final quantities must be the values of milk. If the water is not getting replaced, the initial and final quantities must be the values of water. Okay, initial and final quantities in the units or parts method also works in the same way. Okay, in both methods, the values of initial and final quantities are the values of quantities that is not getting replaced. Okay, actually this is the basic difference, and many videos in the YouTube they don't tell this difference, and in the exam they will write simply the quantities of milk and also quantities of water, and they will get the wrong answer. Okay, that's the reason I am suggesting the quantities that is not getting replaced is the initial and final quantity. Okay, and let's solve some basic level problems based on this removal and replacer concept, so that you can come to know how to use these three methods to solve the problems. Okay, and also I will tell you in what situations we can't use this formula method, and also in what situations we can't use this units or parts method. Okay, if you know what is the normal or basic method, you can solve any kind of problem in this remove or replace concept. Okay, now let's solve some basic level problems so that you can understand clearly. Okay, now let's see the first problem. They are saying that a container contains 100 liters of milk. From this container, 20 liters of milk is taken out and replaced by water. This process was repeated 2 times. How much of milk is now contained in the container? So we need to find out what is the total amount of milk in the container after doing all the operations. Okay, see here they have given the initial quantity of milk is 100 liters. Okay, here we need to find out what is the final quantity. So I am keeping final quantity as it is. Okay, final quantity, we don't know what is the final quantity and we need to find out. And what is the initial quantity? That is 100 liters of milk, right? Now in this 100 liter they are taking out 20 liters of milk. Okay, now equal to 1 minus 20 liters of milk is taken out and replaced by water. So x equal to 20 here. And see what is the total amount of mixture in the container? That is 100 liter. Okay, now how many times we are doing it? Only 2 times, right? So n equal to 2. So we will get final quantity equal to 100. I am sending this 100 to the right hand side. I will get 100 into 1 minus 100 and minus 20, that is 80 by 100. Okay, 80 by 100. Okay, so I will get 100 into 80 by 100 into 80 by 100. Okay, I am writing this 80 by 100 whole square equal to 80 by 100 into 80 by 100. Okay, now I am cancelling this 100 and also 0 0 and 0 0. So I will get 8 is 64 liters of milk. So in the final quantity there is 64 liters of milk. Okay, now let's see how to solve the same problem using this normal or basic method. See here, initial quantity they have given total is 100 liters of milk. Okay, there is no water initially. Okay, so this is initial. Okay, always write initial, removed and added in all the problems when you are solving with normal or basic method, because when you write like this you can be very careful when you are adding or removing the total quantity. Okay, see here, initial, first we will remove the quantity and then we will add, remove, add. Okay, here we are doing only 2 times, that's the reason I am removing 2 times and adding 2 times. Okay, see here, initially the total quantity is only 100 liters, right? Now from the 100 liters we are taking out 20 liters. Okay, now we are taking out 20 liters. Okay, now after taking out 20 liters we are adding 20 liters of water. So we will get 100 minus 20 is milk quantity is, okay, milk, water here. Milk quantity will be 100 minus 20, that is 80 liters, and we are adding 20 liters of water. So water quantity becomes 20 liters. So the total quantity is 80 plus 20, that is 100 liters. Okay, now again we are taking out 20 liters of mixture. Now this is mixture here. Okay, now out of 100 liters, milk quantity is 80 liters and we are taking out 20 liters of quantity. So we will get 0 0 will be cancelled and 2 ones 2 5s and 5 ones 5 and 5 6 30. So 16 liters of milk is taking out from this 80 liters. 60 minus 16 is 2. Now out of 20 liters, see here, 20 by 100 into 20. So I will get 21s, 25 i's and 5 4s. So out of 20 liters, we are taking out 4 liters. Okay, see here, initially the total quantity itself is milk. Okay, there is no mixture here. But here, there is a mixture of milk and water. That's the reason we need to find out in this removing 20 liters, what is the quantity of milk is removing and also what is the quantity of water is removing. Okay, see here, milk is removing by 16 liters and water is 4 liters. 18 by 16, 18 minus 16 and 20 minus 4. So what is the final quantity? 18 minus 16 is 64 is to 20 minus 4 is 16 liters. Now we are adding again 20 liters of water. So 16 plus 20. Okay, here we are removing 4 liters from the water in that 20 liters and again we are replacing the same quantity of water, right? So I am adding 20 liters to this 16. So I will get 64 is to 36. The total quantity will be again 100 liters only. Now this is the final quantity and what is the total quantity of milk in the final quantity? That is 64 liters. Okay, in this way we will solve normal or basic method. See, in the normal or basic method, one thing you need to remember is here initially there will be total one quantity, there will be no mixture here. Okay, but when you are doing second time, the total mixture will be calculated. Okay, here there is a mixture of milk and water, but initially there is only milk here. Okay, so when you are doing second time, we need to calculate what is the quantity of milk we are taking out and also what is the quantity of water we are taking out. Okay, and then we are adding same quantity of water. That's the reason I am adding this 20 here. Okay, so we will get 64 plus that is totally 100 liters and out of 100 liters 64 liters is milk. Okay, now let's see how to solve the same problem using this units or parts method. See here, initial, final. Okay, initially the total quantity of milk is 100 liters, right? Now we are taking out 20 liters of milk. Okay, now after taking out 20 liters of milk, what is the quantity remaining? That is 100 minus 20, 80 liters of milk. Now what is the ratio here? 0, 0 will be cancelled and 2 4 8 and 2 5 10. So we will get 5 is to 4. Okay, now we are doing this taking out and replacing 2 times. So I am squaring these both the values. Okay, now I will get 5 square will be 25 and 4 square will be 16. Okay, now the initial quantity is 25 parts and final quantity is 16 parts. Now we already know the initial quantity is 100 liters. Okay, now we need to make this 25 as 100. Okay, how can we make 25 as 100? By multiplying with 4. Okay, so we will get 4 into 25. Since I am multiplying the left side value with 4, I need to multiply with same value in the right hand side also. So I am multiplying 16 into 4. So we will get 100 is to 16 for 64. So the initial quantity is 100 liters, we got this, and final quantity will be 64 liters in the total mixture. Okay, see here when compared to this normal and also formula, this units or parts method is very easy. Okay, that's the reason I always try to use these both methods only. Okay, now let's see the second problem. They are saying that a container contains 50 liters of milk. From this container, 5 liters of milk was taken out and replaced by water. This process was repeated further 2 times. How much milk is now contained in the container? So we need to find out what is the total amount of milk in the final container. Okay, see here, we need to find out what is the final quantity. So I am keeping this final quantity as it is. Okay, now what is the initial quantity? That is 50 liters of milk, right? 50 liters of milk equal to 1 minus what is the amount that we are taking out and replacing, that is 5 liters, by what is the total quantity? 50 liters. Now how many times we are doing it? See here, initially we are replacing 5 liters of water, that is one time, and in the question they have said that this process is repeated by further 2 times. Okay, so there are totally further 2 times and initially 1 time. There are totally 3 times we are doing this operation. Okay, so n equal to 3. So we will get, I will send this 50 to the right hand side. So I will get 50 into 50 minus 5, that is 45 by 50 whole power 3. So I will get 50 into 45 by 50 into 45 by 50 into 45 by 50. Okay, so I will get 50 and 50 will be cancelled and 5 tens, 5 nines, 5 tens, 5 nines, 45 and 5 twos 10, 5 nines 45. So I will get 9 nines 81 and 81 into 9, that is 729. 729 by 2 times 20. 21s are 23 60 and there will be 12 here, 129, that is 26 26 120 and there will be 90 here. So 24 80 and there will be 10 here, 25 100. So 36.45 liters. So this is the total quantity of milk in the final container. Okay, now let's see how to solve the same problem using this normal or basic method. I have written all the initial, removed and added in the left hand side. So whenever you are solving the problem using this normal method, try to write this in the left hand side. Okay, so that you cannot confuse between the values and also get the correct answer. Okay, and this is for beginner level only, but when you become very expert, you can solve the problems directly and also get the correct answer. Okay, see here, initially the total quantity of milk is 50 liters, right? We don't have any liters of water here, so 0 liters. Now from this quantity we are taking out 5 liters. So 50 minus 5 is to 0. Now we are adding same liters of water to the quantity. So 0 plus 5. So we will get 45 is to 5. Total quantity will be again 50 liters only. Okay. Now from this mixture we are again taking out 5 liters of mixture. Okay, now we need to find out in that 5 liters what is the quantity of milk is removed and also what is the quantity of water is removed. Okay, so 45 by 50 into, that is 5 liters. 5 ones, 5 tens, 4.5. And also in the same way 5 by 50 into 5. So we will get 5 ones, 5 tens, 0.5. So we are removing 4.5 liters from the milk and 0.5 liters from the water. Okay, see here 45 minus 4.5 and 5 minus 0.5. And in the same way we are replacing same quantity of water. So we will get plus 5. So we will get 45 minus 4.5, that is 41.5 is to 5 minus 0.5 will be 5 plus 5 will be 10 and 10 minus 0.5, that is 9.5. Okay. Now again we are removing same quantity of mixture, that is 5 liters of mixture from the total mixture. So we will get 41.5 by 50 into 5, that is 5 ones, 5 tens. So this time we will remove 4.15 liters from the milk, and also in the same way 9.5 by 50 into 5, that is 5 ones, 5 tens. So we will remove 0.95 from the mixture. So out of 41.5 we are removing 4.15. 4.15 is to, out of 9.5 liters we are removing 0.95. On the same way we are adding same quantity of water, so plus 5. So we will get 41.5 minus 4.15, that is 41 minus 4 will be 37 and 36.45. 36.45 is to 9.5 minus 0.95 plus 5, that is 9.5 plus 5, that is 14.5 minus 0.95, that is 13.55. Okay, so the final quantity of mixture in the milk is 36.45 liters. Okay, so this is the total quantity of milk in the final mixture, that is 36.45 liters out of 50 liters. Okay, now let's see how to solve the same problem using this units or parts method. See here, initially and final. Initially the total quantity of milk is 50 liters, right? Now we are taking out 5 liters of milk. Now what is the milk remaining? That is only 45 liters. So we will get 5 tens 50 and 5 nines 45. 10 is to 9. Now we are repeating this process for 3 times, right? So 10 cube and 9 cube. So we will get 1000 is to 9 cube. 9 nines 81 and 81 into 9, that is 729. Okay. So I will get, see we are already know what is the initial quantity, that is 50 liters. But we have got the initial quantity as 1000 liters. Okay. Now we need to make this 1000 as 50. Okay. So I am dividing the same quantity into 1000 by 1000 into 50 is to 729 by 1000 into 50. Okay. See here, the initial quantity is 50 liters, but we got the initial quantity as 1000 liters. Now we need to make this 1000 as 50. How can we make it? If we divide 1000 by 1000, we will get 1. So to 1 I am multiplying 50. So we will get 50 here. Okay. See here, whenever you want to make the value, see here, whatever, suppose if I want to make 1000 as 20. Okay. Suppose I want to make 1000 as 20. How can I make this? I will divide 1000 by 1000. So I will get 1. So to that 1 I will multiply 20. I will get the value as 20. Okay, in this way we will make whatever the value comes in the initial mixture. Okay, whenever it is comes 1000 into 50 or 50 into 1000, something like that, simply divide with same value and multiply with the initial quantity. We will get the answer. Okay, see here, now I need to make 50 liters from 1000. So I am dividing 1000 with same value, that is 1000, and multiplying with initial mixture, that is 50. Okay, in this way we can make this 1000 as 50. Now what we will get, that is 50 is to, that is, and 500 will cancel and 5 ones 520s. 720 by 729 by 20, that is 2360, and there will be 12 here, 129, 26 120, and there will be 90 here, 0.4, 24 is 80, and there will be 10 here, 5, 36.45. Now let's see the third problem. They are saying that a 20-liter mixture of milk and water contains milk and water in the ratio of 3:2. 10 liters of mixture is removed and replaced with 10 liters of pure milk, and the operation is repeated once more. At the end of 2 removal and replacement, what is the ratio of milk and water in the resultant mixture? So we need to find out what is the final ratio of milk and water. Okay, see here, they have given the total quantity as 20 liters. Okay, now in this 20 liters, the ratio of milk and water is 3:2. Okay, now we need to find out, first of all, what is the total quantity of milk and also what is the total quantity of water in this 20 liters. See here, there are totally 3 plus 2 equal to 5 parts. So out of 20 liters, there are totally 5 parts. Okay, now what is the quantity of milk? That is only 3 parts. So 3 by 5 into 20. So we will get 5 4s 20. So 12 liters of milk here. So milk quantity equal to 12 liters. In the same way, what is the remaining quantity? That is water quantity equal to 8 liters. Okay, now what they are saying is, out of this quantity, 10 liters of the total quantity is removed and replaced with 10 liters of pure milk. See here, they are replacing milk quantity here. So the final and initial quantity must be water quantity. Okay, as I have already told you, here they are replacing milk quantity. So initial and final must be the quantities of water. Okay, now what is the initial quantity of water? That is 8 liters. Okay, final by initial quantity of water is 8 liters equal to 1 minus what is the quantity that is taken out and replacing 10 liters by what is the initial total quantity, that is 20 liters. Okay, 20 by how many times we are doing this? Only 2 times, right? So n equal to 2. So we will get 8 into 20 liters, right? 20 liters. 21's 20 and 20 minus 10, that is 10 by 20 by 2. So we will get 8 into 10 by 20 into 10 by 20. Okay, so I will get 10 ones 10 twos and 10 ones 10 twos, 2 ones 2 fours. So I will get 4 by 2, that is 2 ones 2 twos. So water quantity in the final mixture is 2 liters. Okay, so in the 20 liters in the final mixture, the quantity of water is only 2 liters. Okay, milk and water 2 liters. Now what is the remaining quantity? That is 18 liters. 18 liters is milk quantity. So the ratio is 2 ones 2 nines. The ratio is 9:1. Okay, here the quantity removed and replaced is the milk quantity. So the final and initial must be the quantities of water. Okay, here we have find out what is the final quantity of water in the mixture, that is 2 liters. Now what is the quantity remaining? That is 18 liters of milk. Okay, now what is the ratio? 9:1. Okay, now let's see how to solve the same problem using this normal or basic method. Initially they have given total quantity as 20 liters. Okay, now what is the ratio of milk and water? That is 3:2. Now what are the quantities of milk and water in this 20 liters? That is, totally there are 5 parts. So milk part is only 3. So 3 by 5 into 20. 5 fours 20 and 3 fours 12. 12 liters of milk and 8 liters of water. Okay, so out of this 20 liters, we are taking out 10 liters of quantity. So we need to find out what is the quantity of milk in the 10 liters and also what is the quantity of water in the 10 liters. Because here we have mixture, right? Here we have mixture of milk and water. So in the 10 liters, there will be some quantity of milk and also some quantity of water. So we need to find out what quantity of milk is removed and also what quantity of water is removed. Okay, see here, out of 20 liters, the milk quantity is 12 liters and removing 10 liters. Now 10 ones, 10 twos 20 and 2 ones 2 6. So 6 liters. In the same way, the water is 8 by 20 into 10. So we will get 10 ones, 10 twos and 2 ones 2 fours. 4 liters of water. So we are removing out of 12 liters, 6 liters of milk is removed, and out of 8 liters, 4 liters of water is removed. Okay. 12 minus 6 is to 8 minus 4. Now we are replacing same quantity of pure milk. So plus 10 liters of pure milk. So we will get 12 minus 6 will be 6 and 16 is to 8 minus 4, that is 4. Again the total mixture will be 20 liters. Okay, now again we are taking out 10 liters of mixture. Okay, now out of 20 liters the quantity of milk is 16 liters into 20. Sorry, 10 liters. 10 ones, 10 twos and 2 ones, 2 eights. So we are taking out 8 liters of milk. 16 minus 8. Now what is the quantity of water that is taking out? That is, out of 20 liters, 4 parts is water and 10 liters are we are taking out. So 10 ones, 10 twos and 2 ones, 2 twos. 2 liters of water we are taking out. Okay, 4 minus 2. Now we are replacing same quantity of milk here. So plus 10. So we will get 16 minus 8 will be 8 and 18 liters of milk and 2 liters of water equal to 20 liters of total mixture. Okay, now what is the final ratio? 2 ones, 2 nines, that is 9:1. Okay, this is the ratio of milk and water in the final mixture. Okay, here in the beginning itself the total quantity is a mixture of milk and water. So we need to find out in the taking out quantity what is the quantity of milk is taking out and also what is the quantity of water is taking out. Okay, now let's see how to solve the same problem using this units or parts method. See here, initially the total quantity given is 20 liters. Now in this 20 liters, what is the ratio of milk and water? That is 3:2. Okay, now what are the quantities of milk and water? That is, milk has 12 liters and water is 8 liters. Okay, now I have already told you in the units or parts method and also this formula method, the initial and final quantities are the quantities that are not getting replaced. Okay, here milk is getting replaced every time. So here water is not getting replaced. That's the reason the initial and final quantities must be the quantities of water. Okay, see here, initial and final. Initial quantity of water is 8 liters, right? And final quantity of water. We need to know first of all what is the quantity of water that is getting removed. Okay, out of 20 liters, the water quantity is 8 liters. So we are removing 10 liters from the 20 liters. So into 10, I will get 20 ones, 10 twos, 20 and 2 ones, 2 fours. So 4 liters is getting removed from the initial. So after removing 4 liters, what is the remaining quantity? Only 4 liters. Right? After removing 4 liters from the initial mixture, what is the final mixture of water? That is 4 liters. Now we need to say that is 4 ones, 4 twos. The ratio will be 2:1. Now how many times we are doing this operation? Only 2 times. So I am squaring both the values. So I will get 4:1. Now we all know what is the initial quantity of this water, that is only 8 liters. Now we have got the initial quantity of water as 4 liters. Now we need to make this 4 as 8. How can we make them? By multiplying 2 with 4. In the same way, multiplying 2 with 1. Okay, I need to make this 4 as 8. So how can I make it? By multiplying the whole ratio with 2. So I will get 8:2. So the final quantity of water in the final mixture is 2 liters. Now what is the remaining mixture? That is only 18 liters. Right? So the ratio of milk and water is 18:2. That is 2 ones, 2 nines. 9:1. One thing you need to remember is the initial and final quantities in the units or parts method and also final method are the quantities that is not getting replaced. Here the milk is getting replaced, so water is the initial and final quantity. If the water is getting replaced, the milk is the initial and final quantity. Okay, this is the most important thing in this units or parts method or also formula method. Okay, now let's see the fourth problem. They are saying that a bottle contains 64 liters of pure milk, 8 liters of milk is replaced by same amount of water. Again 16 liters of mixture is replaced by that amount of water. The ratio of milk and water in the new mixture is. So we need to find out what is the final ratio of milk and water. Here the removed and replaced quantities in first and second case are not equal. See here, in the first case 8 liters of milk is replaced by water and in the second case 16 liters of mixture is replaced by water. So we can't use this formula method to solve the problem because here the total quantities is different in the first and second case. Okay, in the first case we are replacing 8 liters and in the second case we are replacing 16 liters. So we can't use this formula method to solve the problem. Okay, now let's see how to solve the same problem using this normal or basic method. See here, initially the total quantity is 64 liters, that is milk quantity, and we don't have any water in the initially. Okay, now we are taking out 8 liters from the total milk. So we will get 64 minus 8, and in the same way we are adding same quantity of water to the mixture. So 0 plus 8. So we will get 56:8 equal to 64 liters. Okay, now from this mixture we are again taking out 16 liters of total quantity. Now in that quantity we need to find out what is the milk and also what is the water taking out. So okay, so out of 64, milk quantity is 56 into we are taking out 16 liters of quantity. So 16 ones, 16 fours and 4 ones, 4 14s. 14 liters of total quantity is taking out from the milk. And in the same way, out of 64, water quantity is 8 and into 16. 16 ones, 16 fours and 4 ones, 4 twos. So 2 liters of water is taking out in this 16 liters. Okay, so out of 56 liters, 14 liters is taking out, and in the same way, out of 8 liters, 2 liters is taking out. Now, in the same quantity, we are adding water. So, plus 16. So, we will get 56 minus 14 will be 42 is to 8 plus 16 will be 24 and minus 2, that is 22. 2 11s and 2 21s. So, the final ratio of milk and water is 21 is to 11. Okay, now units or parts method. See here, in both cases, the quantities that are getting changed are different. You can't use the units or parts method directly to find the solution. Because I will tell you why. See here, the total quantity is 64 liters, right? Now, after removing, okay, initial and final. Now, after removing 8 liters, the final quantity becomes 56 liters. Okay, now I am again removing 16 liters of total mixture from this mixture. Okay, now since the first case is removed 8 liters and in the second case we have removed 16 liters. Since the both quantities are different, you can't square them or you can't cube them to find the answer. This is completely wrong. Okay, that's the reason you can't directly square or cube them to find the answer. So this units or parts method will not be helpful when the quantities are different in both cases. Okay, in this kind of questions, you can also solve the problem using this units or parts method. But here the thing is, in the middle of the method, you need to come to again normal or basic method to find the answer. Okay, I will tell you that also, see here. But instead of learning this, the normal method is more helpful than the units or parts method. See here, I will tell you. See, the total mixture is 64 liters, right? Now, we are removing 8 liters of total quantity and adding 8 liters of total water. So, milk and water ratio becomes 56:8. Okay, now from this mixture I am removing 16 liters of total quantity. Okay, now what is the ratio after removing 16 liters? That is same as 56 and 80. Okay, because in the starting of video I have already told you, after removing or no matter how many liters you remove from the mixture, the ratio before removing and after removing will be same. But the only thing is the value of part gets changed. Okay, here I don't know what is the exact value of part, so I am assuming the value of part as x value. Okay, see here, in the starting of video I have already told you, no matter how many liters you remove from the mixture, the before and after ratio will be same. The only thing is the value of parts gets changed. Okay, now I don't know what is the exact value of part, so I am assuming the value of part as x here. Okay, now after removing 16 liters, we are adding same quantity of water to the quantity. So 8x plus 16. Okay, now we will get this. After adding all this quantity, I need to get the total quantity as 64 liters, because we are removing same quantity and adding same quantity. Okay, so the final quantity needs to be same in all the cases, right? Now 56x plus 8x plus 16 equal to 64, right? Now this is the same method that we have done here. Sorry, here. Okay, 56 minus 14 and 8 minus 2 plus 16. This is the same method we have done here. That's the reason, even though we solve the same problem in this units or parts method, you need to come to again normal or basic method to find the answer. Okay, that's the reason, instead of doing this in this kind of questions, try to solve using this normal or basic method only. Okay, whenever the two quantities that are getting replaced are different, you need to solve the problem by using normal or basic method only. Okay, in those kind of situations, this units or parts method or formula method doesn't help you. Okay, that's the reason I am always suggesting you to follow normal or basic method always to solve the problems. Okay, and that's it for this video. Try to solve more and more problems based on this remove and replace concept, and always try to use only normal or basic method to solve the problems. Okay, if you solve more and more problems, you can become expert in solving this remove and replace concept, and also it will take less time for you to solve the problems in the exams. Okay, that's the reason always try to use normal or basic method only in solving the problems based on this removed and replaced. This units or parts method and also formula method doesn't help you when you go to tough level questions or tough level exams. Okay, and for more tutorials like this, please subscribe to the channel. Thank you.